How's that? There we are. Good morning. I noticed that we didn't have any drums this morning, and I have to say I'm terribly disappointed. That's good. That's what we wanted. There we are. So good morning. I'm Andrew Sullivan. I'm the chair of the IAB, and I'm very pleased this morning to bring you the report from the IAB. This is the report from the community. Now, many of you may not know what the IAB does because people keep asking us that, so I'm pretty sure that people don't know. In any case, these are the things that we're chartered to do, and you notice one of those is in black because, of course, we haven't had to do that since Dallas. We've done a bunch of stuff since Dallas. Here are a bunch of things, and I'm not going to go through all of them because this kind of status thing is, I know, very, very dull, but you can get these slides online so you can have a look at it. There are a couple of things on here that we're going to go into greater detail later in this session, but it'll be obvious when we come to those. We also publish documents in the IAB stream, more on the IAB stream in a moment. So here are some documents that we're working on. These ones are the IAB stream itself, our work items, and then there are these items about the RFC series itself. Now, you may notice that last time we had this draft IAB DOI 1, and we said then community review was complete and it's being implemented. And then a few weeks ago, we asked for community input on this draft IAB DOI 04 draft, and we received some comments. And the comments were about the process by which we did this. So the complaint was essentially that we had, asked for community input after we'd already implemented it, and so there's something to this, right? What we've decided is that we're going to do something about this in order to not repeat this mistake. So having something that we've already implemented and then say, could we please have community review on this? Maybe not so useful. We haven't exactly decided how we're going to modify the process for these kinds of documents, but it's going to be something like this. We're going to have a look at, while the document is being worked on, there's going to be a number of iterative cycles where various things are tried out. This is going to be important, for instance, for the XML RFC version 2 and version 3 and the various format changes that Heather's going to talk about in a moment. So we'll have iterative development of that stuff, and then on top of that, we'll have a period where we announce, okay, it's time for community input. And that's our standard community input tradition, but we won't have implemented it yet. We'll be running in some kind of parallel mode or something. Again, we haven't decided exactly how this is going to work. When that is successful, assuming we ever get to success, because of course we could have a failure. I know it's impossible to believe that we could ever have a failure, but we could have a failure. But assuming we have success, we'll finally then declare success, and then we'll say, okay, now community input is done, and we'll publish the thing. And what that publishing will do, it will say, when we make the publication, well, this is what we did. So, things will be done at the end, and we won't be asking for community input on something that we've already done, which admittedly was not the smartest thing I've ever done. So that's how we're going to solve that problem. Okay, now we organize our work into programs, as many of you know. These are the programs. You will note that internationalization is still up there. I mentioned the last time in Dallas, I guess, that we've got some weakness in the internationalization area, and if you're desperately keen to know a lot about internationalization, please come and talk to us, because we would be very happy to have some more expertise there. In any case, these are the programs, and the program page is there. Now, programs are a funny thing. We organize our stuff into programs because, I know this will be impossible to believe, but the IAB doesn't know everything. And so we have to get, outside experts. And also, IAB terms last, you're typically appointed for 2 years. And, maybe there's a work program that lasts much longer than any one IAB member is around. And so we want, long work items to go longer. At the same time, we want to be useful, and this means that we need to be able to get input from people who are experts in these various areas. Now, experts often don't want to just, give their opinion. and then have, the opinion ignored by the IAB, who, believe it or not, also don't have infinite time, and so don't always come up to speed on every single thing that we think about. So we have this problem because IAB statements go out over, or IAB RFCs or whatever, go out over the names of the IAB members, right? And so if I am going to sign something, I don't want to put my name on something that I don't have a positive agreement with. Maybe I don't know anything about it. Maybe I disagree, but probably not. I might not have the time to work up for it. We've had this idea that maybe the programs could, on occasion, they could say things on their own. At the same time, we're a little nervous about this because, of course, the programs are really just creatures of the IAB. So we're trying out some different things. What we're trying to do is see if there are occasions, and we want to be careful about this, but we want to see if there are some occasions when the programs can issue, their views independently of the IAB. And we actually tried this out this time. So the IANA Evolution program needed to respond to the ICANN cross-community working group on IANA stewardship. I know you're all totally engaged with the IANA transition. So we needed to respond to this IANA transition issue. But the time for public comment was quite short. There was no way we could bring the whole IAB up to speed in time. So what we did was the lead of the IANA Evolution program, Russ Housley, he sent a note and said, this is what the program thinks, but note that it's what the program thinks. And we're going to see how this works. I don't promise that this is always going to be perfect, but I think it's a reasonably good idea in some limited circumstances. I don't want people to get the impression, however, that what we're doing is setting up some sort of parallel working group or some completely new thing that we haven't told anybody about or anything like that. What we're really trying to do is, maximize the utility of the work and make sure that the people who are in the programs, can do things when necessary, because after all, the IAB has created these groups in an effort to try to get work done, and we don't want to bog ourselves down in needless bureaucracy. Now, you may remember, although you may forget, but you might remember that the A in IAB is supposed to stand for architecture. And so one of the things that we want to do with the programs is architecture. And so when we organize ourselves into these long-term programs, they're always trying to answer this question: what principles guide the work in the programs area? That's really the idea behind the programs. And once those principles are clear, we might do something else with it. So maybe the Ietf wants to pick it up. Maybe the IRTF wants to pick it up because we don't have principles that are sufficiently defined. Maybe it turns out that it's work that just isn't appropriate for this community. That sometimes happens. It could be, of course, that we discover once we've got all the principles laid out that this is not very interesting work and nobody's going to do it. So there's lots of possibilities. But the basic goal is to lay out some principles and then say, okay, well, here we are. We've done some architecture. Now somebody else has to move on from this. Programs can do this work in just about any way they like. And so, sometimes you do you work on a whiteboard, or you might work on napkins because there's a lot of those in the bar and you happen to be there. You might write some exploratory code, and this is one of the things that people do, especially in our kind of field, right? People write exploratory code to try something out, but that doesn't mean that it's important or valuable or necessarily something you're going to keep. It could be throwaway stuff. So we don't expect the Ietf ever to adopt our whiteboards or our napkins, and that also means that we don't expect people to adopt our exploratory code. I wanted to make that clear because sometimes people are worried that when they see the IAB doing this work, oh, well, the IAB is off doing engineering, and I want to assure everybody that the IAB, when we're doing engineering, we're doing it in the Ietf just like everybody else. All right, as the last item I want to mention in this update, we've got this workshop coming up. I think this is really good work. The IAB has been somewhat successful with workshops that are engaging other communities, and this is a joint workshop on managing radio networks in an encrypted world. And it's joint with the Internet Society, AT&T, and the GSMA. That's going to happen this September in Atlanta. So our workshops so far have been successful when we engage other people like this, and I think this is going to be a good one. Obviously, there are challenges. We've embraced the encryption sort of ubiquitously, and it creates challenges for operators of networks. So this is that's what we're going to tackle there. All right, we have three more items that we want to talk about today. First of all, Ted Hardy is going to talk about an appeal response. This is another item that we have. After that, Lars Eggert is going to come up and talk about the IRTF, and then Heather is going to talk about the RFC editor. So I'm going to introduce them all now, one after the other, and Ted is first.
So as Andrew noted, one of the roles of the IEB is to handle appeals. And in this case, we did receive an appeal during this last period from JFC Morphin. And he appealed the ISG's response to his appeal to them of the approval of draft IETF IANA plan ICG response. We received that appeal on June 22nd. There were a significant number of recusals for this particular consideration. We had recusals from Yari, Mark, Russ, Andrew, and Suzanne. Yari, because he's a member of the ISG, is typically recused in these cases. Mark was the working group chair. Russ was a document editor of the relevant document. Andrew was the document shepherd, and Suzanne has another role in the ICANN world, and so all of them are recused. As it stands, the IAB typically makes its decisions as unanimously as possible. In this particular case, we did achieve unanimity among the non-recused members, which also meets our voting criteria of at least 7 full members agreeing and there being no more than 2 dissents. In this case, there were no dissents. The IAB response is now posted on our website. You're welcome to read the full response. It's also linked in this. You'll find a link as well to the full appeal. The summary of the outcome here is that the IAB declined to annul the decision of the ISG to approve the document. We concurred with their response in their appeal response that appeals must be of actions already taken. That it is not appropriate, in other words, to use an appeal to direct future action. We also believe that the RFC 2026 appeal process was followed in this case, so there's a procedural question of whether or not it was followed. And we noted that some of the complaint here was that the appeal process didn't include mechanisms for doing a whole bunch of other things. And we noted to Mr. Morphin that other processes laid out in our documents, including the working group process itself, remained open to him, and those provided avenues, for example, to have the questions which he poses in the appeals to be answered. And we recommended that he use those to pose those questions. There's one kind of minor fillip to that, was he asked a question of whether or not you could draw a conclusion about the IEB's consensus around a topic from the conclusion of the working group. And while we said, no, in general you cannot, because the IEB consensus may be different to that of the working group. In this particular case, there is an IEB note in the document where the IEB explicitly concurred with that particular document. And so that was the response to the appeal. Lars, you're up now.
Okay. Here on the page. Oops.
All right, good morning. I'm Lars Eggert, I chair the IRTF task force. This is the short version of the status of the IRTF. The long version I gave at the IRTF open meeting, which in this case happened yesterday, so you missed it. We have a record number of research groups meeting. There's 9 groups that are currently chartered. 8 of them are meeting this week. I'm not going to read you the list. You can see it. Basically, everybody but the delay-tolerant networking research group is meeting. But they recently spun out the delay-tolerant networking working group in the Ietf, and so there is work going on here. There's a question whether DTN RG will have enough stuff left to do now that the working group is incubated to continue. We'll discuss that. There's also 3 proposed research groups that are meeting. There's some formatting issue with the slides. One is on how ossified is the protocol stack research group. I think they're meeting for the first time. This is an effort by a few researchers that have measurements about the ossification of the network and how difficult it is, therefore, to do further protocol design. And we'll see whether that can turn into sort of a continuous research group or if it's more like a single meeting. But we'll see. This is the first time they're meeting. I'm optimistic. Second group is the Human Rights Protocol Considerations Group. They've met in Dallas already as a proposed research group, and they have had sessions at SAG, for example, at the Ietf. So this topic has been discussed in the Ietf for a bit already, and they're trying to work in the IRTF on the topic. I encourage you also to go to them. And finally, on the bottom, which you can't read, is the proposed thing-to-thing research group. Again, they also already met in Dallas. They had 2 full-day meetings, site meetings, Saturday and Sunday, and they had a regular slot yesterday already. And so there seems to be quite an active community. The room was more than full. Next time they better ask for a bigger room. So it looks like we might have a few other research groups forming. If you have an idea for another research group, come talk to me. You now know what I look like. And you can also email irtfchair@irtf.org. Our open meeting was yesterday, and we're going to review a research group which is not Gaia with the IAB on Friday. The Gaia chair couldn't, one of the Gaia chairs couldn't travel here, so we decided we were going to pick the network function virtualization research group for a Friday review. My status, subjective status on the activity levels, unsurprisingly has a lot of stuff in the green since there's a lot of meetings, a lot of activity. Maybe with the exception of the delay tolerant networking research group, I mentioned them, and also the congestion control guys are not so busy as they usually are, so I put them in the orange this time. We have an IRTF stream for RFCs. It's a much smaller stream than the Ietf stream, for example. So this is our activity level over the different meeting cycles. We published 3 documents since IETF 92 and 2 since IETF 91. Since I didn't give this in Dallas, these are the 5 RFCs that we published since IETF 90. 1 from the software-defined networking research group. 1 from the yeah. We should not do this in the morning again, by the way. Hey, maybe I changed the charter text on the website. You never know. 1 from the ICNRG, 1 from the Crypto Forum Research Group, and 2 from the Network Management Research Group. God. Moving on. So we're doing the Applied Networking Prize for a while now together with ISOC. We are in the 2015 cycle, for which we had 33 nominations. We had 46 for 2014. So we're around, the same ballpark number. We have a selection committee of some IETF folks, some IRTF folks, some academics. We also, now that we've been running this for a few years, included some past prize winners to help us pick the new prize winners. We picked 5 winners for 2015. Some spoke in Dallas, 2 more, Haya and Joao, spoke yesterday at the IRTF open meeting. They were very good talks. These are usually my favorite talks of the entire week, and that's not because I'm biased. I actually think they are amongst the best talks. And we're going to have 2 more at IETF 94 in Yokohama. And the nomination period for the 2016 cycle of this is actually open now, has been open for a few weeks. So if you are reading research papers, and if you read something that you think, hey, this, could influence standardization, or this is really interesting for, applied research that the IRTF is doing, please nominate that paper. Also, if you've written one that you believe follows the criteria that we want to award awards to, nominate yourself. Nobody but me can tell whether it's a self-nomination or a third-party nomination, and I don't care. All I care about is having good papers to choose from. So there's self-nominations are strongly encouraged. Many of the past winners actually self-nominated, so it's good if you do that. I want to briefly mention Comcast again. They have come to Matt Ford from the ISOC, who arranges the financial side of this, and said, hey, we like this award. We are, we want to support this somehow. Can we? And unsurprisingly, we said, yes, certainly you can. If you are here and you would like to support the ANIP, talk to Matt, talk to me. We're very open. We, will use the funds to make the prize better, hopefully attracting more participation and making it a nicer sort of thing than it already is for the researchers that come. We might give out more. And finally, I want to mention another workshop that is going to happen. So ACM SIGCOMM is a academic society on networking that runs a bunch of very high profile, very good academic conferences. And they've recently become very interested in getting closer to industry again. And I'm part of the advisory board on the SIGCOMM side for this. And the Internet Measurement Conference, which is the SIGCOMM conference on measurements, meets in Tokyo actually, in the week before the IETF meets in Yokohama. So we are like 30 minutes on the subway apart from one another. And so we are using the opportunity of having that co-location to do an academic workshop on the Saturday, which is Halloween, October 31st, at the IETF site in Yokohama, to get the two communities together. The important thing on this slide is the URL. All of the rest is screenshots, so you can look at this yourself. There's some more text. So it's co-sponsored by the Internet Society, the IRTF, and ACM SIGCOMM, which it wasn't on Andrew's part of the talk. It's not an IB workshop, it's an IRTF workshop. Participation, there's two ways in which you can participate. It's again, an invitation-only thing. That's usually only because we need to do some crowd control, right? We have limited space. If you are an academic, either an IETF participant who is an academic or an academic on the SIGCOMM side, and you've done work in this space recently and you have an academic paper, all you need to do to ask us to invite you is to send us, a citation, paper title, here it's published here, and you're done. If you don't have one of those, but you still would like to come, we ask you to send us a short position paper on your thoughts on the topics of the workshop. This shouldn't be surprising to anybody. On the IAB and IRTF side, we frequently use the same mechanism. The submission deadline is in August, which is why I'm mentioning this now. So you have some time, you don't have a lot of time. We promised to tell you by the end of August whether you have an invitation, and probably a little bit later tell you whether we put you in one of the sessions as a speaker, and the workshop date is October 31st. Thank you.
There we go. Hello, everybody. For the folks who are stuck standing in the back, there are some seats here in case your legs get tired. Heather Flanagan, RFC Series Editor. I will keep this brief. If you want to talk to me in person, I do have some office hours later today at the RFC Editor desk, which is right over there. First thing I wanted to mention is the RFC Production Center SLA. Congratulations, you guys aren't slowing down. You're producing a lot of documents. We know this SLA actually isn't a very good one. It's not measuring the right things. And in 2016, we actually have a very different SLA model. And just for fun, we went ahead and looked at the last 3 quarters, applying that to the 2016 model. And in that model, we actually are meeting the SLA. That model was put together with input from the RFC Series Oversight Committee, from the IETF chair, IRTF chair, IAB chair, etc. So those are the numbers. It will look like a very different chart, and you'll see an example of that at the next IETF meeting. Speaking of the production center, every 6 years we are required to send that contract out to bid. That process is underway now. We are at the stage of receiving bids. Bids are welcome to come in until August 3rd, at which point there is a vendor selection committee in place that will review those bids, make a recommendation to the IAOC, and then a decision will be made in the September-October timeframe, at which point we award the contract and move on from there. If this is all news to you and you're curious as to what the statement of work looks like and all those, what the SLA is described as, please go to the IAOC RFP website and it's on that page. So since, I'm going to actually reverse this slide here. Since March of 2015, last IETF meeting, we've completed 2 of the projects that were on my list. One was DOI assignment. That was fun. And also Google Scholar indexing. So now all RFCs on the RFC editor website, which is the canonical location for them, are properly indexed in Google Scholar. So that took a lot of back and forth discussion, but it is done. It is fully indexed as of June. For projects that are still in flight, there's the RFC format. How many of you know that I'm working on the format? Oh, that wasn't as many as last time. I'm a little worried. I am working on revising the RFC format to be more than just plain text ASCII only, and more on that on the next slide. I'm also working on digital preservation. So the RFC series is a way to disseminate information about best practices, standards, etc., to the world. It's also an archival series, which means we're responsible for making sure that this material is available in perpetuity. And since it is all digital material, it's not like sticking it in the library somewhere and just assuming that the paper won't degrade, et cetera, et cetera. There's things that there are best practices. There's an archival industry that describes what you're supposed to be doing here. And it's not stuff we've really done in the past. If you're curious about the details and if you really want to see me get excited and geek out about it, because I had a whole lot of fun writing that draft, it's draft IAB RFC preservation. Please feel free to read it and comment. I hope to actually send it through the publication process real soon now. Okay. We're also updating the RFC editor website, which I think last received a refresh sometime in the mid-90s. So it's a little, it could use some work. So that project is also underway. So with the format work, we are revising the process by which the actual drafts associated with the project will move forward. Andrew mentioned something along those lines a little earlier, and what exactly that's going to look like, we are discussing. The statements of work that refer back to those drafts as the requirements for what need to happen are undergoing review within the tools development team. If you are curious and would like to comment, that is easily discoverable through the tools mailing list. Many of the drafts have been updated since the last Ietf meeting. If you would like to see a list of common questions I've received about this, a list of exactly what drafts are associated with it, there is an FAQ that you are encouraged to look at, and if there's a question on there that you have that isn't on there, please let me know. So as I said, there's many of the drafts have been updated. Some of them are new, such as a prep tool draft, which we don't actually intend to publish as an RFC ever. It's basically just to organize our thoughts. And I really want to thank the design team that's been helping me with all of this. I mean, the community input has been great, but this design team has put in an incredible amount of work. We have calls every other week to go over this, and we're reaching out to people from New Zealand all the way to Germany. So we've got lots of different time zones underway, a lot of people holding a lot of pens, reviewing a lot of pages, and I am very appreciative of their time. Some of these people are at the point where they're lurking, but since they're on the list, I know I can reach out to them and say, can you take a special look at this over here and get some feedback? There's various avenues of communication. There's a wiki, which I admit I'm not as good at updating as I should be, but it is out there, and I do intend to get back to that to clean it up with what's going on today. There's the RFC interest mailing list. You're welcome to send in questions about what's happening with the series, what's happening with specific drafts, for example, in the format work. And of course, if you've got questions, comments, concerns, or feedback that you want to send in about the series or about how I'm doing, the RFC Series Oversight Committee is always happy to receive that input. And there we go. Thank you very much.
Thank you. Thank you, Ted, Lars, and Heather. I know that you all come here all the time for these status updates. That's the real reason you're all here. So actually now we have the cool part of the morning. And so I noticed that there are lots of people standing, and there are seats. So if you want to find a place to sit down, you might find it more relaxing, or maybe you want to stand because you feel better standing. In any case, we have this cool topic now, which is vehicular networking. I'm very excited about this because, well, I've already heard some of these talks a little bit anyway, and they're really nifty. We have two speakers today. Christoph Sommer is an assistant professor at the University of Paderborn. He's part of the Embedded Systems Group, and his research is focused on questions regarding traffic efficiency, safety, and security aspects of car-to-X communication in heterogeneous environments. William White is chief scientist at Security Innovation and the technical editor of the IEEE standard 1609.2, specifying communication security mechanisms for vehicle-to-vehicle and other communications. He has been involved in the cryptographic standards group IEEE 1363 and ANSI X9F1, and he has contributed to the CFRG and the Ietf TLS working group. After their presentations, the IAB's Russ Housley is going to moderate the discussion. So I would like to welcome Christoph and William and Russ.
Hello, everyone. It is my absolute pleasure to shine today a light on a topic that I think hasn't received nearly as much attention as it should have, which is vehicular networking, wireless networks of vehicles driving on the road. And by way of a motivating example, consider this example where we have a blue car driving down the road, and the idea here is to have the vehicle driving two cars in front of the blue vehicle brake sharply. And the outcome of this situation should be pretty clear. It will be too late for any of the other vehicles involved in this to react, especially for the blue car, with the outcome that we will get a crash, possible injury, possible loss of life even. And now the solution is obvious. The solution is to warn the driver or to warn the vehicle if it is the vehicle that is driving. And the way to do this is wireless communication. The exchange of information may be broadcast by the vehicle that is braking sharply, maybe even broadcast by the obstacle because of which the vehicle is braking sharply. And all of these concepts are not really new. This goes back to the 1970s, actually, where we had bold ideas already of visionary infrastructureless solution, visionary ideas of highway automation. But all of these ideas at that time were simply unsupported by the technology that was available to us. So there was early interest, even by industry, but absolutely no market success of these systems. And this stayed for quite a while until the 80s, where we had a paradigm shift. Things moved away from being infrastructure-less to being infrastructure-assisted now, from complete highway automation to not much than just driver advisory. And one of these systems you can see on the top right-hand corner. Where we have a traffic light equipped with an infrared beacon that is informing the driver of upcoming traffic light phases and makes it possible for the driver to adapt to kind of a green wave situation. But this has an obvious downside, which is if we do this transition to infrastructure-assisted systems, infrastructure needs to be in place for the system to work. So that means we have kind of a chicken and egg type of standoff, where without deployed traffic lights in that case, nobody wants to buy the system. With nobody buying the system, there is no incentive to equip more traffic lights. So again, things stalled until the 90s, where we had new cellular technology. Cellular mobile networking made it possible to have this infrastructure then, to be able to disseminate information to cars. And this is actually where we had the first early, very early car-to-X systems that were informing drivers of certain things that made it possible to have an upstream back to the internet in that case. And these examples are the ever famous OnStar 1995, BMW Assist, and many, many more that followed. But this made vehicles dependent on a cellular network for providing these services. So again, little things changed until the 2000s, when a sharp increase in computing power made it possible to now deploy fully distributed and highly reactive ad hoc systems. Cars directly communicating to other cars on the road. And this triggered a number of activities. So in the late 2000s, lots of coordinated research programs sprang up, memoranda of understanding of cooperation in the next years between the three biggest car manufacturers, between Europe, US, and Japan, trilateral agreements. which culminated in a lot of numerous and large-scale field trials that tried out this technology in kind of a close-to-market scenario and concluded that this technology is hugely beneficial. The NHTSA predicted that two very simple applications alone, intersection movement assist and left turn assist, could prevent some 100,000 crashes and save 1,000 lives annually if this system were to be deployed. And this is where we are now. This triggered the NHTSA in August 2014, so roughly a year ago, to actually say they were going to propose rulemaking. In Ietf parlance, they must. New vehicles must be equipped with that kind of technology, vehicular networking, to be allowed to operate on US roads. And in fact, there are early commitments by car manufacturers to, by 2017, equip new models with that technology. So this is to come. This is technology that will be deployed on the roads. And it fuses very nicely with a second trend. And the second trend is that autonomous driving is moving from being purely academic, playing around with equipped cars, to being very, very close to market. You all know the Google car and the many cars that follow, the many cars that are right now driving on the roads. And that fuses autonomous driving and cooperative driving, which is what vehicular networking brings us to build something like automatic driving, platooning, where we have one truck driving in front that is still steered by a human, and all of the other cars in the platoon following just centimeters apart, autonomously following this one car, made possible by vehicular networking to be able to react in time to all of the acceleration, deceleration, steering of the truck leading the platoon. Now, these are the applications. This is the motivation. What makes this work, obviously, is networking. This is why we're here. And it can be argued that vehicular networking represents a third evolutionary step in networking as we know it. We used to come from traditional networks, wired, non-moving, statically configured, to the ever-present mobile ad hoc networks, now wireless, now mobile, now dynamically configured, now to vehicular networking, which is a completely new field of deployment. And indeed, the first way of casting vehicular networks was as vehicular ad hoc networks, so as a pure application of mobile ad hoc networking principles to vehicles. This turned out to not work so well, and now there is a gap to fill. And this gap has been filled on the lower layers already, and is commonly termed DSRC, dedicated short-range communication after the frequency band in the US that this is operating on, which is kind of our new lower layers that we can build on. And the first idea was to simply adopt technology that is already there, to adopt Wi-Fi technology, wireless LAN, 11A, B, G, N, which turned out to be not so good a fit. Mostly because they were designed to operate in one of two modes that are mutually exclusive, infrastructure mode and ad hoc mode. And the switching between those modes and the association to basic service sets is very time consuming, actually taking a lot of the time more in terms of association time than is being afforded by the very short communication opportunities that two vehicles might have on the road. There's also problems of massively shared spectrum. This is operating in the ISM band. And of course, lots of physical layer effects that just make everything break apart. So what was done is wireless LAN was extended. Wireless LAN has a lot of extensions, and so what has been done is just to form a new standard, DSRC. Lots of these extensions have again been collected to form a new basis, and one of these extensions obviously is 11E, quality of service. Higher priority frames are sent sooner on the channel. 11J, half-blocked operation, a more robust way of encoding frames at just 10 megahertz of bandwidth, which makes this operate in harsher environments. And the very, very new 11P standard, an OFDM file layer that was designed for operation at 5.9 gigahertz in the DSRC band. And an amendment to the standard that brings with it a completely new operation mode called OCB mode outside the context of a basic service set. And this makes the standard work. OCB mode, very simply put, is simply allowing devices to at all times transmit frames addressed to a wildcard basic service set. That makes it possible to communicate without any association process. Simply broadcast the frame and hope for the best. But of course, this shifts coordination from the Mac to the applications. Now there needs to be something in place that coordinates when frames are being sent on what channel and when devices are listening on that channel. And this is important because there are many channels to pick from. There are at least 5 channels in the US and in Europe each, allocated only to vehicular communication. That is reserved. Nothing else may communicate there. At no license cost, but very strict usage rules in the sense that only vehicular networking can operate there. So that means there's new approaches to be sought there also. And if we think about information exchange on the higher layers, one might think that this is something that can be addressed with traditional protocols, for example, with routing. But if we consider the applications that are supposed to be deployed on vehicular networks, it becomes very obvious that this will be hard to do. Consider all of the safety applications that are purely one-hop broadcast information dissemination. This is where safety is very relevant. Routing is simply way too much overhead to make this work in the very short term. But also think about non-safety applications like traffic information systems, where such a system might really shine. Here, routing will simply lead to the system not scaling well enough because information has to adapt to different granularities, to incorporate updates as the information is traveling through the network. So also here, routing is not applicable. And that leaves a small subset of in that case, I called it comfort applications, where we can actually do streaming of data to the cars. But even for a small subset of those, the ones that disseminate information in a very near field, routing is just inapplicable. It will be too slow, it will be too much effort in terms of data overhead wasted. So we have a lot of blank space to fill up, a lot of blank space for protocols to be deployed that make this system work again. And these protocols are there. They have been researched in the past years. It's just a necessity to assemble them into a complete stack. And this stack needs to meet a lot of old challenges. Nothing new in wireless here. Multicast communication, low load, low delay, we all want that. But there's several new challenges to be met as well. Highly dynamic topology, safety, partitioning of the network being the norm rather than the exception. Fragmented networks still operating as they should. Very complex mobility patterns, high-speed mobility, but at the same time very predictable mobility, are also things that can be exploited and have to be addressed. In fact, there are 3 standards that are addressing these challenges. In the US, that is IEEE 1609 Wave. In Europe, that's ETSI ITS. And in Japan, that's RFT 109. And I want to take some minutes to briefly introduce these standards to you. Let's start with IEEE Wave. That is the US standard. The idea here is pretty simple. The idea here is to take to a large degree, unmodified protocol stack. To say we probably have only one physical layer. We might have 2 physical layers. On top of that is the standard wireless LAN MAC. On top of that, a new layer is introduced, channel coordination. That is the layer that makes sure that we are tuned to the right frequency at the right time. And then on top of all of this, a new protocol is deployed, Wave Short Message Protocol, something that is very lightweight, that makes it possible to exchange data with little overhead. Now you see on the left-hand side, TCP over IPv6, that is still standardized, that is still possible, but it's not really in the scope of this standard. So what does channel coordination do? Channel coordination's job is to make sure that even with just one radio, it is still possible to receive critical information. And that is made possible in IEEE Wave by recommending that devices tune to a well-known channel called the control channel at periodic intervals synchronized over all devices. So the default interval is 100 milliseconds for all of the devices to tune to a well-known channel and exchange information there. And this control channel is then used to disseminate these high priority information, to disseminate service announcements of services that then are being operated on all of the other channels, the service channels. And that brings with it a lot of problems. synchronization effects by the channel switching that are being addressed in more recent iterations of the standard, but they are still present in there. So the European standard ETSI ITS went a little bit of a different route. The motivation was to learn from the lessons of WAVE, to not specify alternating access to the control channel, but instead to focus much more on multi-radio. And one of the core recommendations that is given is, if you only have one radio, you better leave this tuned to the control channel at all times. If you have more than one radio, you are fine to use the service channels for whatever you want, but if you just have one radio, you keep it on the control channel. The stack is also much more mature, but also much more fully featured in the sense that it proposes a lot of facilities, a lot of services that are already operating standardized on the stack, one of which is cooperative awareness messages, periodic, up to 10 Hertz, depending on the situation, safety messages that are being disseminated and are supposed to inform a vehicle driving about the state of surrounding vehicles, to inform them about speed and location of the vehicles. Second big component is a cross-layer component in ETSI ITS, which is the decentralized congestion control component, whose job it is to regulate locally access to the channel, to monitor the state of the channel, and if the channel is being sensed to be very busy, to keep local applications from accessing the channel too frequently or with too much transmit power or with less than optimal modulation coding schemes. And that is a core component of the stack. The second core component of the stack is geo-networking, which makes it possible to disseminate information addressed to a topologically scoped set of vehicles. The simplest one is the topologically scoped broadcast, the simple N-hop neighborhood flooding, informing cars driving 2 hops away from me of certain information that they might be interested in. There's also geo-broadcast, where I push information to a certain point addressed by longitude, latitude, and a shape, and then disseminate it in that area. And there's also geo-unicast, where I route information to exactly one car and one car only. And I help this routing process by annotating the request longitude, latitude information of where I guess this car will be. Now, where does this leave us? This leaves us with a lot of applications, each tailor-made to a specific use case, but each also using a very different part of the network stack. One of these applications is IETF 60911, electronic payment, first and foremost for tolling. There's SAE's path signal phase and timing, which disseminates information about when traffic lights are supposed to, will be turning green, so making drivers aware of that so they can adapt their speed. There's ETSI-CAM, cooperative awareness messages that I already talked about. This is reflected in IETF SAM, ESM, basic safety messages, the same concept really. There's ETSI-DENIM, which is messages informing about events that have happened, disseminated using this geo-routing. But aside from all of these applications that can be put on the stack, this also opens up a whole lot of new opportunities. And one of the biggest ones, in my opinion, is the merging of in-vehicle and vehicle-to-vehicle communication. Now, for the first time, we can do sensor data fusion of local vehicle sensors and information received from other vehicles. So for any obstacle detected by a computer vision system, we can check if other cars have seen this as well, and vice versa. If some other car tells me there is an obstacle, I might try to double check this using my computer vision system. And of course, this also opens a whole lot of security and privacy concerns of such a system, which William will be talking about very shortly. So that's it from me almost. If you need more information, if you want more information, I can advertise a textbook I authored on vehicular networking, which is geared for exactly that. We also have the IEEE Vehicular Networking Conference, so you are very well invited to join us in Kyoto in December, or to just peruse the proceedings where much of what I talked about has been discussed about already and published in the shape of the scientific paper. So, thank you very much. Over to William. Oops.
Thanks very much, Christoph, and thanks very much to the IETF for inviting us to present. It's an honour to be able to present to an organisation that's contributed so much to networking and communications across the world. So Christoph's given you a very good overview of what's been driving the adoption of cooperative ITS, the ability to run applications vehicles, the ability to avoid collisions and potentially save lives. As he mentioned, there's a number of security considerations that need to be dealt with. So the baseline questions I'm going to be looking at are what is connected vehicle communication security? How is it different from other communication security? I mean, inside the IETF, there's a number of working groups on security in different settings. Why did we need to go and do something different? So also I'll talk about specific mechanisms that we're using and where these are located in the protocol stack. And the security challenges that we had to face in cooperative ITS, they include a lot of the usual ones. Confidentiality, integrity, authenticity, authorization, non-repudiation. These are standard security services that applications or communicating devices need to consume in order to make sure that they're getting the operations that they expect. Obviously, the specific requirements will often be application specific. So Christoph mentioned this cooperative awareness message where vehicles tell each other where they are. That's kind of the key message that enables collision avoidance. And obviously, you want everybody to be receiving that. You don't need confidentiality for that. Confidentiality gets in the way of the application working. But for other applications, such as any commercial transaction, obviously confidentiality is going to be very helpful. So we have these usual settings, these usual security goals, and they need to be applied in the appropriate way for your use case. Additionally, in the cooperative ITS setting, we have concerns like privacy. So if you have this radio in your car, and the plan in the US is that cars will be mandated to be equipped with these radios sometime in the 2020-2022 time period, you don't want that to give you automated speeding tickets. You don't want that to enable wide-scale tracking. So that's something that needs to be addressed. We have constraints on communication, on channel capacity. We have 10 megahertz channels, 6 megabits per second. It's not a lot if you've got a 300-meter range and potentially 200, 300 vehicles in that range all trying to communicate at the same time, especially with hidden node issues. So we need to ensure that the overhead, the communications overhead from security isn't too much. We also have constrained devices. Things in the automotive setting are expensive. You're building devices that need to have a lifetime of 30 years, that need to work in temperature ranges that you don't find in the usual server room. And some OEMs tell us that even a megabyte of automotive grade storage is very, very expensive for them. It makes a difference to the cost of manufacture of the car. And some things that would be very easy to do if you had a gig of storage become very hard to do when you only have a meg of storage. So you have to take that into account as well. As well as the fact that these devices might have relatively low powered, relatively slow processors. There might be constraints on what HSMs, hardware security modules, you can include, again, because of the environmental and cost constraints. So we have those constraints, and additionally, we have the constraint that in the US again, we want to enable single radio devices for cost reasons. So we have these devices that are going to be very good at sending, not necessarily so good at receiving information from the internet in general. Those are devices that need to be kept up to date with their security information. They need to receive new certs as appropriate. They need to receive certificate revocation lists as appropriate. So there's a number of unusual challenges that you don't find in a general kind of internet protocol. I also want to flag some ways in which what we're doing is similar to things that have been done in IETF. There's some inaccuracies on this slide. I apologize for those. So there is I think it's a BOF at the moment on IGS IP over multi-op in vehicular ad hoc networks. The IGS I don't know what you call something before it's a WG. The IDS group is working on that. They have a bar meeting after this, I think. We've also developed a different certificate format from X509, and there's a proposal to extend TLS to use that certificate in the handshake as well as the existing X509 certs. We do some automated certificate issuance techniques that are similar in spirit to what's going on in ACME, although, again, different technologies. We're doing some certificate management techniques that are similar to those that have been developed inside PKICS. And in general, I think it's fair to say that we're moving from the time when it was appropriate to focus on the things that were different about cooperative ITS to the things we're doing that have already been done in terms of certificate management, what goes on the back end, the management networks. And one thing I hope that we'll be doing over the next few years is working much more closely with existing technologies and existing technology groups to make sure that when it comes to cert management, we don't reinvent the wheel any more than necessary. So the specific topics I'm going to talk on in here, I'm going to talk a bit about the trust model, why we ended up developing a different certificate format from X509, what we use it for, and the threat model as well. I'm going to talk a bit more about those privacy concerns that I touched on earlier. I'm going to talk about security considerations for advertised services. So again, Christoph mentioned you get informed on the control channel that services are available on the service channel. What could go wrong with that? And also to talk about security considerations with geo-networking, this multi-hop protocol that's being used more in the European setting than in the American setting. So the trust and threat model, there's been a lot of talk about the threat model for collision avoidance. You get in a message and that message alerts the driver and says, look out, a collision's about to happen, you should brake, you should swerve. Now, obviously, if you get a false alert, that's bad, but the question is, how bad is that? If you get a message saying there's something bad just around the corner, swerve now, there's some cases, here, where there's the thing. There's some cases where swerving would probably be a bad idea. But in general, swerving is a decision that people take a small amount of time to make, and they take environmental considerations into account. And even if this were to be automated again, you'd assume that the automated driving would take into account other sensor information, map information. And so we don't consider that a false positive, a false hazard alert is going to be directly hazardous to life. At least not in proportion to how the benefits of a correct hazard alert. At the same time, you don't want people to be plagued with false positives. One thing that they've discovered in the automotive industry with things like lane departure sensors, those cameras underneath the car, is that if people get more than 2 or 3 false positives a week, then they start to ignore the system, and if possible, they look for ways to turn it off. So we need to manage compromising the system such that the number of false positives people get can be kept to a manageable level, an acceptable level. And so that means you can't have just anybody send messages. You need some kind of authentication on the message. But you can live with a small amount of compromise so long as you have mechanisms in place to manage the impact of that compromise. So that's your classical PKI approaches like certificate revocation. And then there's also potentially risk from false negative. You don't get an alert when you're in a hazard situation. And that's not going to be a problem for a while, but in 30 years' time, when we reach full penetration in the US, people do react to the circumstances they're in. There's some research that shows that people drove slightly more recklessly when seatbelt laws came in. There's research that shows that people drive closer to a cyclist wearing a helmet than a cyclist not wearing a helmet. And so people will adapt their behavior to have expectations that this system works as well, which means that if you're in a situation where there's some kind of denial of service attack going on, you don't get an alert, it's quite possible that in 30 years' time that will lead to more accidents happening than would happen under the same traffic situations today. So obviously that's a long-term problem. It does need to be addressed. Probably you need some kind of user interface notification that look out, your collision warning system isn't reliable at the moment. Please pay attention. You should be paying attention anyway, but we mean it. Please pay attention. So that's the threat model that we're working inside. We want to authenticate messages, and we want to be able to revoke misbehaving devices. So when we authenticate, we're authorizing the message. We're saying that the sender is entitled to send the message. What's the trust model for that? It's application-based. So, for example, if I'm sending a basic safety message, that's identified by an identifier called PSID, Provider Service Identifier, or in Europe it's called ITSA ID. PSID says this is a basic safety message, and my certificate says I'm allowed to send a basic safety message into the PSID. And if there's granularity of permissions inside that application, those are encoded in the SSP, the service-specific permissions. I've got an example on the next slide, but essentially it's up to the CA, the certificate authority that issues the certificate. When it issues the certificate, it has to check that the device requesting the certificate is entitled to those permissions that it's requesting. So looking at this example, you have the cooperative awareness message, here I am, and there's an extension defined to that that lets the sender claim to be an emergency vehicle and say, get out of my way, I'm a police car. So those are both identified by the same ITSA ID, it's hex 24. But if you have the null SSP in your cert, that means you're only allowed to send the here I am version of the message. If you have this 3 bytes 00040, then that also means you're entitled to claim to be an emergency vehicle. And the receiver of the message has to check at the application level that the SSP is consistent with the contents of the message. That can't be checked by the security services, because obviously the security services can't process, can't parse every individual application message. So this consistency check is part of the specification of the application itself. Any application that uses this model needs to say what is the consistency condition between different SSPs and the message contents. And again, the CA is in charge of checking that devices that get issued certs are entitled to those permissions. We talked about performance constraints. So channel capacity, to address that, we're using ECDSA elliptic curve digital signature algorithm with 256-bit curves. That's 64-byte signatures. That's to be compared to messages that are about 75 bytes long. So the overhead's quite large. And of course, you have to not just attach the signature, you have to attach the certificate, which itself typically has a signature as well. So the security overhead is more than 100% the size of the message itself. It's still small as security overhead goes for public key systems, but it is significant. In the US, we've mitigated that slightly by allowing implicit certs. That's a technology that's owned by BlackBerry, where the signature bytes can be omitted from the cert itself. For intellectual property concerns, that's not being used in Europe at the moment. But it certainly mitigates a lot of the performance concerns we have in the US. Another performance concern is, you can have up to 600 or more incoming messages a second. And even on a desktop PC, you can't verify that many ECDSA signatures. So there's two options. One is you use hardware acceleration. That's the approach that the Europeans are in general taking. Another is that you filter messages before you decide whether or not to verify them. So if you're running a collision avoidance application, you look at all the messages and say, is this likely to indicate a collision? And if not, you don't bother verifying it. If it does indicate a collision, you verify it before you raise an alert to the driver. And obviously there's a gradation between the two. Those are the two extreme positions. But those are the way that we're managing the performance concerns. And to manage the concern that we had about it being easier to receive than to send to the CA, we've developed this nice technology which we call butterfly keys that use cool crypto that I can't go into, where a device can upload a single cert request at the start of its lifetime. That allows the CA to generate an arbitrary number of certs for that vehicle that are unlinkable by any eavesdropper. And that lets us manage the peak load very nicely. The the certs are just stored on the network. Whenever the vehicle gets its intermittent network connectivity, it can send up a short request saying, I'm ready for download now, and it can download all the certs that it's entitled to. Obviously, if it's been caught and revoked in that time, then it doesn't get new certs. On privacy, we don't want you to be tracked. We certainly don't want you to get an automated speeding ticket. Getting an automated speeding ticket needs to be addressed by legislation, unfortunately, because you are going around sending out your speed. But what we don't want is somebody who records you here and you here to be able to tell that those were both transmissions from you. And one way they could do that is record everywhere in between and reconstruct your trajectory. That's impossible to stop. And in fact, right at the moment, it can be done. Your automated tire pressure sensors give out a trackable wireless signal. So an eavesdropper who's everywhere already can track you. But an eavesdropper who's only in certain places, we don't want them to be able to do that. So one thing we do is you change your identifiers, your MAC address, application level identifiers. Those all change from time to time and simultaneously. For certificates, it's more complicated because you can't just generate a new certificate on the fly. You need to get it from a CA. So the model at the moment is that every vehicle is issued at least 20 certificates that are valid for a week, and it can adopt its own strategy to change between them. It can change every 5 minutes. It can change after the first 5 minutes, and then again when it's getting to a known destination, it can do some other strategy. And 20 certificates is a minimum. Many vehicles we hope will have more, and that lets the vehicle break up its track and hopefully confuse the attackers who can record you here and here, but not in between. Obviously, if you're issued a lot of certificates, if the CA knows that all of those certificates have gone to you, then an insider at the CA can track you. Or if the CA database gets compromised, anyone can track you. And so we split up the cert issuing process into a number of different components such that no individual component knows the collection of certificates that have gone to a particular car. The CA produces certs in an order determined by the RA, so the CA doesn't know which certs go together, and then it encrypts the certs back to the vehicle and sends them to the RA for distribution. So that, again, no component knows which cert belongs to which vehicle. No component knows which collection of certs go together. But we built in interfaces to allow revocation. Under certain circumstances, you can do what's called student resolution, where correctly formed requests from one component to another will let you say, okay, these two certs go together. And we have a compact revocation system where you can issue a single entry on the revocation list, and that revokes all certs for that vehicle. Although one thing that's nice is that if you're revoked at time T, you can be tracked going forward from that time, but your movements before that time remain private. So if you started driving in January and your car was compromised in June, your movements from January to June are still private. So it's a little bit about the more complicated communications models, geo-networking, service advertisement. Geo-networking, Christoph talked about a little. Messages can be multi-opt. A single device can create a message and other devices will forward it over the network. Now, obviously, that's a classic denial of service scenario. I can produce a single message, and as a result of that, a large number of packets are produced. And that's managed partly by congestion control, but also by security, by communication security. When I create a message for forwarding, I have to sign it, and it has to be verified before it's forwarded. And this is actually the reason why the European model believes in a higher throughput of verified messages than the American model does, because geo-networking is baked into the system so much. And that's a nice way of reducing congestion, and it has a further queued optimization, which is that if you're signing at the network layer anyway, and if those packets aren't going to be forwarded onto some other medium, then you don't need to sign at the application layer, because the packets come from a single trusted source. So the one signature guarantees the entire thing. So if you look at a kind of high-level software architecture of the OBE, the onboard electronics, onboard equipment, in Europe and America, you see that by and large, Europeans who talk about CITS security talk about it as something that happens at the network layer. Americans, or people who work in America, talk about it as something that happens near to the application layer. Christoph also talked about service advertisements, and they have their own security considerations. So you're driving along, and node by the side of the road says you can stop here for electric vehicle charging information, point of interest notification. There's high-speed tolling, or not even necessarily stop here. You can consume as you drive past. And it also says if you go to this service channel and access this service, here's how you set your channel access parameters. Now, there's a number of possible risks there. One is that you simply get advertised the service that is phishing. You get advertised the service that's being run by a bad guy, and you exchange your data over that service. And they learn things about you. That's not the service advertisement's job to solve. If you're deploying a service, it's your job to secure. The service advertisement just says the service is available. And yeah, the service advertisement may in fact advertise a service that's running on some other device altogether. So we don't consider that the service advertisement can take responsibility for making sure all advertised services are good. So buyer beware. There's going to be a consistent theme. Another problem is if somebody advertises a bad service, that gets in the way of valid services. So an example is somebody advertises tolling on the Safety of Life channel. So everybody goes to the Safety of Life channel, they exchange tolling messages, and the congestion means the Safety of Life messages don't get through. So it's a very straightforward denial of service attack by creating false traffic on the channel. And there, again, that can't be addressed by signing anything. That has to be addressed by policy. So all devices in the system need to know what you're allowed to do on what channel. They need to enforce that themselves so that bad advertisements of those type are ignored. And developing that policy is an ongoing project that's, to be honest, isn't complete yet. And finally, there's the risk that responding to a service compromises your privacy. So if I consume a service that hardly anyone consumes, then the fact that I respond to it means it was me. And here again, we're kind of going buyer beware. That if you're choosing to sign up for that service, then you're choosing that you're doing it in the knowledge that there's a potential privacy violation from the fact that you're one of the few people using it. And it's up to you to manage that, to choose to consume the service not very often, or to find some proxy to obscure your service communications. So while that's fair to say, there's one outstanding research area, I think, in privacy, which is privacy for in the multi-application case. So a single application might be a fingerprint for my device. And it's fair to say, well, if you're using that application, take your own precautions. But if you have multiple applications such that the combination of them is a fingerprint for your device, it's not clear that individual applications can be expected to manage that properly. So it seems that down the road, CIDS devices should support some kind of application separation, so an eavesdropper can't tell two applications are being hosted on the same device. A natural idea is that you have a separate virtual device for each of the applications. It's yet to be seen if that works, but that's a research direction I'm very interested in. So finally, this has been an info dump. There's a lot of stuff going on. We have a lot of unique constraints, a lot of points of contact with existing technologies. We've come up with a system that we believe meets very well the requirements of the day one applications and the constraints that we've got. But there's still a lot of future challenges. So one is integrate properly into, for example, the Internet of Things security network. Cooperative ITS is clearly going to end up as a subset of M2M in general. So moving our mechanisms to fit into their frameworks is going to be a major project over the next few years to make sure that we can scale the way we want to. We need to manage congestion in an adversarial setting. That's going to be very difficult, not least because denial of service might have real impact in the future. So that's something that needs to be researched. We need to harmonize policy about which applications can use which channels. We need to learn more sophisticated communications model. Really extend this geo-networking idea, load groupcast, that kind of thing. And our final problem that no one's solved yet is that we're using ECDSA. If a quantum computer is invented, That means that all ECDSA signatures can be forged. Cars have a lifetime of 30 years. Who's to say there won't be a quantum computer inside 30 years? But all other signature algorithms that are believed to be quantum safe are too big. So if you invent a quantum safe signature scheme with short signatures, then you may well see what you've invented be in every car in the world ever at some point. So there's an interesting challenge for you. Okay, thanks very much.
So thank you. One thing I'd like to observe before we open the mics for a few short questions, we're running a little bit behind, is this might be yet another example of a system that was built to do something but also carries IP packets. And it could be that becomes its primary use, as we have seen with some other systems that were built to do something else but also carried IP packets. So if we could keep the number of questions small, but of interest to the large group, I'm going to open the mic lines. Henning.
Henning speaking. On the first presentation, this has somewhat unfortunate memories of WAP again, and like creating a special protocol and stack for just one application. So I wonder, particularly with the emergence of widespread 4G LTE for many of the applications that were indicated, the non-safety application, the non-vehicle-to-vehicle type applications, where this kind of feels like it's outdated before it even ever gets deployed.
Christoph, you want to handle that?
It kind of feels that way, yeah.
Sorry.
The basic problem with mobile networks is that they promise a lot. They will be, I think, hugely beneficial, especially in the phase of market rollout of the system, because if nobody has an 11P device in their car, then, well, I'm the only one on the road. I need a cellular uplink to be able to benefit at all from the system. I do think they are not so good at working for safety in the near field at full deployment, because that would mean deploying a massive number of base stations alongside the freeways, alongside the highways, and also in the city, something that right now these cell sizes are just too large. The second problem that cellular mobile networks have is, first of all, you have a dependency now built into the system. You are dependent on the operator of the system to not charge you or to charge you at reasonable rates. And to allocate a reasonable amount of spectrum to you. LTE can deliver extremely low delays at extremely low latency if sufficient resources are allocated to this use case. And that will be very interesting to see how this plays out in a real world deployment.
Dave?
They were all ahead of me, but okay. Dave Crocker. So the question of security, this was a fascinating talk, difficult, extensive topic, diligent consideration. Thank you for that. My question is about practicality, reliability, scalability, and performance. You touched, of course, on all of those, but my sense is that we have had no production mechanisms in this space. I don't just mean mobility, I mean in terms of security, that have approached anything like the scale or performance requirements that you've cast. And if I'm wrong, I'd like to hear about that. And if I'm not, is there any basis for knowing when we're going to be able to meet the criteria that this kind of system is going to have?
Yeah, so that is a valid concern, especially given the unique constraints of the automotive environment. There's a number of different hardware vendors. I could name three off the top of my head. NXP have in fact announced that they're developing silicon or they're developing the ability to make the necessary hardware in the necessary volumes. Will it work? Well, we've got some time to find out. GM are deploying in 2017. The bulk of American deployment isn't going to be till 2020. And this, to be honest, the question of scaling is something that's fairly low on the list of concerns that I hear about, because these are by and large silicon vendors who are already in the automotive industry, who already have experience making secure devices, maybe in different sections of the company. But the general assumption is that these are organizations that know what they're doing. And I would say we'll find out if they actually do.
Okay, at this point, I want to close the mic lines to make sure we have enough time for the things that are coming up. Next.
Alistair Woodman, one question and a comment. So question is, have you thought about putting cost metrics in the messages to stop spamming and other types of overuse? I think that was probably a big failure in some of the technology that the Ietf developed, and internet in general. So have we cost metrics in email, for instance, we wouldn't be suffering from the spam problem. So that was my question. Have you thought about that? Second one, observation was, I understand that if you cross the bridges or the tunnels in New York, they track the toll tags and all those other types of information. And one of the first things that lawyers do in divorce cases is immediately subpoena this information. What possible belief do you have that this is not going to be used against most drivers of cars in the future?
Yeah, so those are two good questions. On spam costs, so if you're looking at single hop safety of life messages, there's no kind of proof of cost you can put in them that would really help, because the damage is done when they're sent and they tie up channel capacity. So, but it's an interesting idea potentially in geo-networking. It's one that I don't think is being considered. It might be more effective, in fact, than signing. That's certainly one to look at. As far as privacy goes and subpoenaing your routes, again, that's a great point. Yeah, I think the thing to bear in mind is again, especially in America, the government's aware that they're mandating this, so it's going to be looked on very suspiciously, and that the whole purpose is to save lives, and the effectiveness in doing that goes as the square of the penetration rate. So 1% of people at the margin who turn it off results in a 2% drop in effectiveness. That's not what you want. And so, yeah, there's a limit to what the federal government can do. That kind of law is made on a state-by-state basis. But everyone that I talk to takes very seriously the idea that statements should be made as strongly as possible. This won't be used for law enforcement. It won't be subpoenable. There's a line. We have these Amber Alert systems in the US where if a child gets kidnapped, then that information gets widely broadcast. Would that lead to a car being revoked and being tracked? That's yet to be decided. That's just hypothetical. So it's clear that there's a gray area. But at the same time, everyone is very serious about not doing anything that would hurt people's faith that this is purely intended to be a safety of life system.
Dan
York, relaying for somebody in the Jabber chat room, but I'll also say I appreciate the presentation. Personally, while I look forward to some of the convenience, the security and privacy issues certainly are concerning. But the relay is from Balaji Lengyo from Ericsson, and he asked the question remotely: will it be a government requirement to allow vehicle tracking like we have lawful interception today? So will it be a government requirement to allow vehicle tracking?
Yes, I think I just answered that. The intent is to do as little as possible that would detract from its use of the safety of life system, including hurting public faith in it.
Christian
Wittemar, Microsoft. I really appreciated your presentation of privacy issues and how you have this system of having multiple certificates to mitigate tracking. And that's an issue that we are going to find in other systems, not just vehicles. I mean, you could see people tracking various wearable devices and stuff like that. So that's a question for us. I mean, do you have any plan to carry that kind of technology in other IETF working groups and for other domains?
I don't have plans, but if the technology is useful, I mean, it's all published, it's all public. None of it is subject to patent, with the exception of implicit search, which are going out of patent shortly. So it's available for use, and I'm very interested in talking about other ways it might be used. I mean, bear in mind that we're building this PKI that's going to be capable of issuing 1,500 certs, or sorry, I can't multiply by 20 now. It's going to issue 1,000 certs a year to every vehicle on the road, so it's going to have massive scale, and it should be possible to also use that for other applications. So the infrastructure will be there to support other uses, and I'd be very interested in exploring what their other uses might be.
Over here, please.
Thanks, Russ. Robin Wilton from the Internet Society. I'm grateful to the panel for raising a number of the ethical issues that clearly crop up in this domain. So far, my experience has been that the discussion of those issues has been around fairly simple problems, like what happens when a vehicle has to choose between running over 4 pedestrians or injuring the driver. I think we need to go further than that. For instance, at what point will the algorithms in a vehicle perhaps decide to crash into another manufacturer's vehicle instead of one of their own, or to crash into the less insured or the person with the worse lawyers or the higher net worth. So I'm interested to know whether you're aware, the panelists are aware of any industry initiatives to explore some of those more nuanced ethical issues and the development of the algorithms that will put them into practice. And clearly this is an interest of mine and through my work in the Internet Society. So if anyone is interested in looking at those issues, I'd be delighted to hear from them.
Yeah, I mean, it's a very interesting topic. It's more automated driving than this driver alert use that we're thinking about at the moment. Obviously, those two are going to merge as time goes on. So right now, with the mandate coming down the pipe, people have really been focused on just getting the things to work. There's been a lot of banging metal boxes off walls. But clearly, it's a topic a lot of people have been talking about, and over the next 10 years, I think you'll see people really getting into it.
I'm sorry, I previously closed the mic lines, Randy. Bob?
Hi, Bob Hinded, Checkpoint. Two things you said, or one of you said, that bothered me. You have 3 currently radio standards for this, like per geographic region. That's really broken. Come on, just one. I mean, I'm not a manufacturer of any of this, but this is just, you bang heads and get that together. The other is the discussion about the limitations of the computers you can do with these. I mean, you can do a Raspberry Pi for $35. It's the amount of processing, memory, storage you can get. Those curves are going down so quickly. If you limit your design to what you're hearing from the current manufacturers, it's going to severely limit what you can do. You should be pushing on this and assume it's going to get a lot better very quickly.
Christoph, you want to handle at least the first part of that?
The only thing I can say is I wholeheartedly agree. I mean, the good thing is the lower layers are settled. So the Mac, that is common to all of them. The upper layers, they differ by a lot, yeah. And that has to change.
Okay, last one, Charlie.
I'm Charles Perkins, yes. I have 2 hopefully very quick questions. One first is, I really enjoyed the presentation, and presumably part of the motivation is to get work going in Ietf. But isn't this an area where there would be a lot of, let's say, impact from possible government regulation and requirement? And the second question is, it seems to me that there's a really large difference between making solutions for cars that I drive and cars that are self-driving. So I wonder if you have any comment about whether these would be actually 2 distinct efforts.
Christoph, you can handle at least the first of those.
On the higher layer, I do think so, yeah. On the application layer, there will be huge differences, I guess, depending on who this information is for, if it's a human or if it's an automated vehicle. On the Pi and Mac obviously they don't care. And I think even in between, the changes are not so large that need to be made if the stack is built in the right way. And that goes back to oh, now he's gone. That goes back to the previous question. These stacks have to be aligned very much towards being future-proof and towards being sensible in scale. Right now we have one stack that is pretty much bare bones, and one stack that is trying to solve everything and standardize everything. So I really think the future should lie somewhere in between.
Okay, one more time, could we thank our speakers? And
Apparently I'm turned off. I am pleased and honored to welcome Mr. Hulun Zhao, the Secretary General of the ITU. Mr. Zhao has come to an Ietf meeting before, but this is his first one as Secretary General, and we're very pleased he has joined us. From 1999 to 2006, he was Director of the ITU Standardization Bureau, or ITUT, which many of you may be familiar with. He has spoken of the importance of strong relationships among standards development organizations, such as that between the ITU and the Ietf. He was elected Secretary General at the ITU Plenipotentiary Conference in November 2004 and is here today to say a few words to us. Please join me in welcoming Mr. Hulun Zhao.
Yeah, good morning, ladies and gentlemen. It's a real great pleasure to be with you this morning. This is my traditional starting words. But since, as you mentioned, I had some experiences of cooperation with the Ietf. So my first meeting with the Ietf was in July 1999 at Oslo. Then I learned that, that the Ietf people don't wear ties. And they don't say good morning, Mr. Chairman, or Madam Chairman, or lady, or something like that. They said, hi, I'm here. So I just learned from Williams White's presentation, and he wanted to send a message, hi, I'm here. I can be here, that I can repeat the same thing, hi, I'm here. But anyhow, from that message, I also learned something else, that he gave us security considerations, new solutions, and I also met with our chairman of ICANN this morning, Stefan Krecker, and he was also area director of security. And ITU worked in this area for a long time. You remember that 1988, ITU produced the famous recommendation X509, so public key encryptions. And this is still very important standards, used by our internet family. So ITU and Ietf has worked very, very closely over the last 2 decades. But of course, since I'm here with my ties, because I just come from my meeting with the Prime Minister of Czech this morning, so I cannot go to see him without my tie. And then, that I did not see anybody with wear ties. Let me take out my tie. Please prepare another prompt. This is something maybe not many young people know. This is the T-shirt I received at the 46th Ietf Plenary held in Washington, D.C., November 1999. Sally told me I only have 5 minutes. Please don't count this time as part of 5 minutes. Yeah? I wear this for you. Is that nice? I cannot remove my tie because after this meeting I have another official meeting. Yeah, don't blame me. Yeah, don't blame me. And from this slide, I also find some other interesting things. For example, they talked about the ETSI standard. I remember in 1999 when I participated in the 45th Plenary Assembly of Ietf under very kind invitation of my good friend Fred Baker. I saw him now, and at that moment I really don't know what the Ietf was, but I heard that the Ietf is a very good Internet Engineering Task Force, and this is a new environment, not similar to ITU's environment, because ITU is so-called intergovernmental organizations, and ITU standardization work as back as 1865, when the first international telegraph regulation was established by ITU. From very beginning up to recently, still, it's membership-driven organizations. And you might have to say that this is some kind of top-down standardization process. And the IETF is something different. It's from a bottom-up. So I'm very pleased to see this kind of gathering this morning. That a presentation given and then challenged by or inquired by different experts. That may not be easily arranged in the IT process. But anyhow, whether you have a top-down or bottom-up, they all worked for the market, for the new technologies. Therefore, when 1999, Fred invited me to join that one, I was very pleased to join. And then some of my friends told me that, you have to be prepared. You might be shut down, because this is a totally different environment. And but in the evening, when Fred invited me to make a speech, a presentation of ITU history, I think instead of 5 minutes, people told me, okay, this time, sorry, ask me 5 minutes. And I was there for 35 minutes. And I was applauded by Internet IETF families. Partly because of another reason, that in that evening, I signed agreement between IETF, W3C, and ITU, and AC to support ICANN. And AC was some stories. In the morning, I learned that story because there was not a general support to get AC be part of this agreement because there was considered as not a global standardization organization. It's a regional organization for Europe, so that should not be there. So in the morning, Fred organized consultation meetings, asked people to vote. That's also first time for me to understand the vote in such a way. It's not with a ballot. But then he found that it's difficult to understand whether it's really supported or negatively turned down. He said, I do not understand whether you really support or you want to turn down. Can you vote again? Then I found that the people, then he said, now it's agreed. So that was the story I learned that moment. Of course, 5 minutes is very short. I don't want to stay too much of this time. But it was then, in the evening, we signed agreement, 4 of us, to support the ICANN as a technical liaison officer, organizations. And later on it changed to some other. And then we, 4 of us, rotated roles to join the ICANN board as a technical expert. And then, at that meeting in the evening, I think that the chairman of ICANN, Robert, and the carpenter, Fred Beck, they all published the messages on their website to say that this is historic day. This is a new page changed between ITU and IETF. I think that the message should be still there. I don't know, 16 years later, whether this new page is returned or we have to open another new page. But anyhow, as Secretary General of ITU, I would like to strengthen the importance of IETF for the development, of internet services. I like to highlight the importance of cooperation between IETF and ITU for standardization work. I always have this idea that, where we have so-called need of cooperation, which means you may have some competitive work there. But anyhow, I wish not damage the environment, just to fight for our own sides. That when you have this issue of cooperation, when you meet some competitive environment, we should look at very good opportunities to find some compromise. And we did that under the leadership of Fred Beck. We developed memorandum of cooperation between ITU-T and Ietf. I hope that document is still there. And over last decade, we see very good development of cooperation between ITU-T and Ietf for the MPLS and some other areas. We had a very good cooperations. And also from the presentation of this previous topic, we talked about the intellectual property. And we talked about the intelligent transport system. Now, ITU is also working in this area. We work with ISO, IEC, and European EC to address this intelligent transport system. And every year in March, we organize a workshop in Geneva, just prior to the opening of Auto Show in Geneva, to talk about this issue. So I'm very pleased to see a lot of useful ideas here. I'd like to encourage further cooperations between IETF and ITU-T and ISO and the others for the benefit of the global society, for the future intelligent transport system. And of course, I also found that from that presentation, they talked about the IoT, Internet of Things. As you might have noted that IoT was largely promoted by ITU as early as in 2003, 2005. And I'm very pleased to advise you that at the beginning of June this year, ITU-T agreed to set up a new study group for Internet of Things. We call it the study group 20. And again, this time, this is new to our ITU process because we normally establish our study group at the Plenary Assembly of ITU-T. And this is the first time at those internal meeting, administrative meeting, so-called TSAC meeting, that people agreed to set up. I still remember another very good comment from Fred Beck, that in 1999, I was at the plenary. I told them that ITU is changing its environment from 4 years approval period now moved to 18 months. And we are going to 9 months. And very soon we try to speed up our process to 3 months. And then Fred Beck said that you are moving too fast. I think that he has reason. Sometimes it's not that good to move too fast. That you have to, particularly with your intelligent transport system, too fast may not be that good. Sometimes we have to be realistic. Anyhow, ladies and gentlemen, I think that that 1999, 14th of July, 1999. I believe that was one of the Wednesday, because that is traditionally IETF have its administrative assembly. And this time, under the kind invitation from Cathy, and she come to me last year saying in September, she said, can you come to join us again? I said, it's a great pleasure. If I'm elected as Secretary General, he said, no, you will be elected. So after my election, October last year in Busan, she come back to me again. Can you join us? IETF meeting Hawaii. Hawaii is the favorite place for Chinese for me. I like the group, but unfortunately I can't make it. So then she suggested that check today. I said, yes, let me block this date. So I blocked this date from last November to make sure that I'll be placed to come back to IETF families once more again. So I'm very pleased in the end I got this opportunity to meet up you. Of course, this morning, unfortunately, this is not the administrative assembly, it's a technical assembly. And you are talking about the technical issues. Since I have to be back to Geneva tomorrow, I cannot join this administrative assembly tomorrow. So that sorry to disturb your process of a technical debate. So let me just repeat my message here, that I would like to strengthen cooperation between ITU and ISOC, Ietf, IAB, ICANN for the benefit of our global families. Of course, global families are not talking about those already connected online. Let me tell you, last week I was in Madagascar, Comoros, and these two countries, Africa, east part of Africa, these island countries, the internet penetration is still less, around 5%. And globally, our developing world is around 10 to 15%, but that two countries even lower. And even the development in Czech, for example, is around 70%, as announced. But still, we have 30% not connected yet. I met with Prime Minister of Singapore, Mr. Lee Hsien Loong, at the beginning of June, and he told me in person that don't believe that everybody in Singapore is already connected online. And he gave me a story that yesterday, that means 1st of June, he met people on the street and he told them that for any question you want, I can send you by email. And those two people told him that I do not have email address, which means they are not connected, at least the way they're in Singapore. So that Prime Minister told me that don't believe that everybody is connected. Of course, Minister tried to tell me that these immigrants, they may not have phone address. But anyhow, that this is the case. And according to ITU statistics, according to your statistics as well, 2/3 of people has not connected online yet. And half of the population has not connected by mobile phones, although we have 100% penetration everywhere. But still, you have more mobile phones in your pocket. That means if we divide by 2, that the half population not connected yet. So this is a topic I discussed with the Prime Minister Czech this morning. So I'd like to invite head of states, head of government to support the further development of ICT and telecom everywhere in the world. We need their support. We need a further investment to improve our infrastructure, to increase the security, to offer the better quality of services to our population. But there is a very, very strong perceptions that the ICT and telecom is self-developed industry. And in many countries, they consider this is a profit-making industry. Therefore, you don't need to give further attention to support them, to give them further investment. But just imagine, those people not connected yet are those people in the poor area. Not much profit-making for the business community. So we have to work even harder. And in Madagascar and Comoros, when we talked about this with the president, with prime ministers, they even told me that for them, more importantly, they should have energy, power. When I met with the president of Comoros, without the power, we were just in the room without power, without the electricity. So for them, the electricity is even more difficult. So to connect with these people is really a challenge to us, and we have to work hard. And through United Nations process, we noted that with the planned replacement of MDG by SDG, among 17 goals of SDG, new goals after 2015, only 2 mentioned the reference of ICT and telecom power to support social development. It's not enough. So I invited head of states, head of governments to support us with their political support, with their social support, so that our industry, ICT, telecom industry, mobile industry, internet industry, can have further investment from public, from private, and have a good support from the whole community. So I also encourage you, maybe not only to talk about those new technologies for those already connected, I also encourage you to find innovations to support those people not connected with some technologies, feasible, sustainable, and accessible. So this, and also, that should be, with the price acceptable to those poor people. So that is not easy. It's challenge. But anyhow, I'm pretty sure with good cooperation from our industry, from our private sectors, government, and whole society will be benefit from this innovation, from this strong investment. I think that the 5 minutes is already reached, so Sally asked me to step down. So let me just say last word. I wish you all great success. I'm very pleased to see that again, after 16 years in Europe, we still have the room full, and we still have experts, dynamic, energetic to work on the new technologies and still keep this bottom-up approach. And I think that is a great success of Ietf family, and wish you all success in the future. Thank you very much. Of course, try find time to join ITU activities as well. We will welcome you to ITU, and some of you are already members of industry, be our delegates, and unfortunately you have to wear ties here. And but anyhow, you know that next time if you come without ties and anybody criticizes you, you bring them to my office and tell them that the Secretary General not. No, I wear ties. But we okay, thank you very much.
As you know, we often have activities here, and on Saturday we had a hackathon here in order to build and deploy some of the code that we're working on. So we have here a T-shirt for you from the hackathon. So a new one, that's right. Thank you so much.
Thank you very much. No. Let me say that this is also very dynamic industry. You know, this T-shirt was sponsored by Nokia. Nokia was very strong to, that moment. But, today we do not see Nokia anymore. So this is a very tough competition. That is another message I conveyed to our head of state governments, that don't believe that this industry is always, profit-making, self-development. If anything, goes wrong, or if they're not as strong anymore, there could be eliminated very easily. So don't just consider them always profit-making. Give them maximum support. Let them to become strong in the market. So thank you very much. Thank you so much. Thank you. I keep it this way. Thank you.
All right. Thank you so much. We are, as many of you may have noticed, running a little bit over time. So I have a question for you so that we can decide what to do next. Is there somebody who wants to ask the IAB a question? All you have to do is kind of like wave. Anybody at all? All right, then Kathleen, please come and join us. So this was one of those things where I felt like, I'm going to show my age, but Johnny Carson trying to decide whether he's going to allow the Animal Act on. Turns out not, and we're going to have Kathleen talk to us about the KARAS. Yeah, right, you didn't think I was referring to the IAB. Thanks, we got about 8 minutes.
I will make this as quick as possible. So I'm here to talk about the IAB and ISOC Coordinating Attack Response at Internet Scale workshop that took place in June. And I'll skip the intro slide just to save a little bit of time. So what we did here was we brought together researchers, CSIRT. So a CSIRT is a computer security incident response team. We had national CSIRTs, some smaller CSIRTs, nice cross-section. And from operators, we had large groups that deal with attack response, but typically specific to use cases, which tends to be, in my opinion, more efficient. Researchers, and the researchers tend to be focused on a specific attack type because there's so much to do in each of these areas, either as an analyst or as a researcher, that you tend to focus in on a specific attack type. And we covered quite a few attack types. Vendors are really important because they can put out automated controls and help with some of the efficiencies. And of course, standards representatives. Now, these folks have never been in a room together. They meet in silos. So it was exciting for them. It was great for us. And we had some really nice outcomes, one of which is a library of response efforts that we're able to collect. And the CSERTs in particular want to amend the questions that we asked, fill it out more, and make this available as a template so that additional CSERTs can fill it out. And the reason for that is they put in questions, or we had questions like, what kind of data do you share? What's accessible? How do I participate in your effort? How can I collaborate with you? So we can figure out how we can tap on these resources better, and they can figure out how to work with each other better. Even the national CSERTs had differences in what they did with their data and how they went after attacks. And some of them went after different attack types. So even additional coordination amongst them will be helpful, in addition to the operator-driven models that might be focused on phishing or something else. And this looks different than my computer. All right, I'll deal. The small and medium organizations, the big problems are that they have no capacity to deal with data coming in. And I guess let me take one step back. I think I'm rushing a little too much. The use case driven are more efficient, but what you're hearing from governments and from sharing and analysis centers that are focused on industries, let's say, or even regional ones, is that you have organizations coming together, they meet, and they share attack data. So let's say I work in an organization, a large organization, I do analysis on my network, I find out some sources of attack, I share this into this group, then other people collect this information and they can pull it back out into their networks, and then they can deploy controls. So if you think about that, there's no way a small organization, a medium organization, and even most large organizations have the resources to do that type of work, to have an analyst smart enough to be able to contribute data in so that they can pull data out, because nobody wants somebody to participate in these groups and just taking data, right? So those models don't scale. And where it starts to scale is where you have the analysis centers, but there's more that we can do to help with efficiencies. And that was the core of this problem. I have a lot more materials on the problem space if folks are interested and you want to get a bit deeper. And so recognizing this, one size doesn't fit all, and we're trying to drive folks to more directed, actionable, and automated responses. So we had all these various groups in the room, and we're really just trying to get them to talk more and see how they can tap into each other. I like to use the anti-phishing working group as one of the examples of efficiencies, because they have a warehouse, a data warehouse, and actually some of their work they had brought through the Ietf, which is nice. So their data warehouse for phishing attacks is used by all different members, including organizations, vendors. So there are some vendors that work with law enforcement, and they help with the actual takedown of malware distribution sites. And the vendors that are doing that, they're not making any money off of that. It's just a nice thing that they're doing. They work with law enforcement, and then they update the database. Then all of the browser vendors are one of the consumers of this information. So they do some analysis on these malware distribution sites with using a small number of analysts, and that informs, is one of the sources that informs the browser block lists that get deployed in every major browser out there, right? So something like that really scales, and it'd be great to see more efforts like that. The botnet takedowns, those are things that scale. So since we had such a diverse group, we broke up discussions into various categories, and the information sharing groups talked about their template submissions, and that was very useful. Then we had a panel of DDoS and botnet researchers, and interestingly enough, and vendors. They don't really talk to each other, right? So you have DDoS attacks that are sourced mainly from botnet activity, and you'd think it'd be pretty logical for the DDoS folks to share this data with the botnet folks so they could take down the offending botnets and maybe would get a little bit better. So it was good to get them talking. Then DNS and RIRs. So this was interesting because the RIRs brought forth a whole bunch of data that they have publicly available that the participants just were unaware of. And so one of the outcomes of that, it's on the next slide, I'll just say it here quickly, is that we may need to help them to make that data more accessible and scale better, because how it's offered now is not in a way that's going to scale once
the various CSERTs and analysts start tapping into those resources. But it was very useful to have that combination in the room with the DNS providers and RIRs. Of course, we talked about trust privacy, and then the IAB wrapped up with what can we do next? How can we help? So here are just some of the next steps. There'll be a formal report coming out that will detail more. One that was pretty interesting, and I hope we can do something very near term on this, is educate more on some of our BCPs, like BCP 38. It came up over and over and over again by the CSERTs, the DDoS vendors. It's not implemented. BCP 38 is just ingress-egress filtering. Very, very basic, right? So going back to when I first started, I don't want to say when, that was basic. We just deployed that. And it would be good to see it at service provider edges. It would be good to see it at enterprises and figuring out, how do we make that known? And maybe perhaps we get a few people in the Ietf, maybe the Edu team. Maybe we get ISOC to help promote these, but go through other BCPs and figure out how do we educate better on the best practices so we can limit the scope of the threat space. Let's see. One of the other outcomes was a lot of discussion on protocol options to exchange data. There's too many. DOTS is starting up just as a working group this meeting. They'll need something pretty specific to their use case, and there seems to be a lot of momentum there, and they're informed by existing research and work for telemetry data. So that should be pretty good. But in MILE and SACM, we have a couple of protocols where we could use assistance from protocol experts so we could progress a couple of drafts and make sure they're the right things to do and that they'll scale appropriately, because the solutions out there don't scale well enough. And I can say that because I wrote one of them. So let's see. One of the ones that doesn't scale, it's much older. And then there was a lot of interest in future meetings to get this group together. So maybe that's something that we could do with ISOC. All right, so I'd like to thank each of the program committee members and our sponsors for making the workshop possible and bringing these folks together. The report will be forthcoming. If you have interest in this, please let me or some of the program committee members know, or start helping out in MILE and SACM on the specific protocols, and I can give you more information on where exactly we need help. Thank you.
Thank you, Kathleen, for rushing that. I know that was a little bit of a rush. Finally, I want to thank all of you, and I want to thank our speakers today. I'm not going to call the IAB up here, but I want everybody to be able to, because nobody's going to talk to us, and we're out of time. But I do want the IAB all to stand so that at least you can identify us, so that you can yell at us in the event that there is a problem. Not so much that we can be thanked, but rather so that you can, come up to us and so on. We are in fact approachable, and if you have concerns or so on about what we're doing or what we're not doing, we certainly want to hear about it. So please do. Thank you very much, and thank you for your patience as we ran a little over. Enjoy your lunch.